Yes, sir.
So like, don't worry about the previous concept of light chapter. I'll be giving you backup, and Harshit as well. You will be joining as well in those classes. So don't worry about that. Like Karishma and Shweta has already joined the batch since last class. So you all having the previous backup. So don't worry about that. Okay. So the topic which I'm going to cover will be like I will be starting from scratch. I will tell you the basic concept, how to start, like how to draw the image of the object of lens, like in place of the lens, like basically if the lens, like if the object is placed in front of the lens. So Harshit, are you there? So do you remember the like the image formation of mirrors? I have completed that topic
Yes,
with
sir.
you in the class.
Yes, sir.
Okay, okay, that's great. So image formation of mirror is similar to the image formation of lenses. Clear? Okay. So let's start with the term. Let me write one example, like one definition here, which is lateral inversion. Sorry, lateral shift. Sorry, not lateral inversion. It's lateral shift. So lateral shift in the previous class, I've told you that. Just give me a second. Where is it? Now you can see if the ray is basically goes from one medium to another medium, it basically deviates from its path because the speed changes. Just a second. Okay. Yes or no?
Yes, sir.
Because of the change of the speed of light in different mediums. That's why the deviation we see the deviation from its original path. So basically, this perpendicular distance, basically this, just give me a right. So this distance is called as lateral shift. How much the ray has been shifted from its original path. Is that clear to all of you? Is this clear what I've spoken right now?
Yes, sir.
Any doubt? Why is everybody so silent? What happened? Karishma, Abdullah, and Hashid, is everybody fine?
Yes, sir.
Okay, okay.
Yes,
So
sir.
okay, just please. So yes. So let's start with the term lateral shift. So lateral shift is the perpendicular distance between the original Abdullah, you are saying something to me. Okay. Abdullah, I will talk to you later in this class. Okay, don't worry about it, dear. Okay.
Okay, sir.
Original path of incident ray and the emergent ray. Coming out of the glass slab, out of a glass slab. Clear? Maybe it can be any other medium as well. It's not restricted to glass slab. So whenever the light changes from one medium to another medium, there would be some refraction. Yes or no, everybody?
Yes, sir.
So because of that refraction, there is a perpendicular, there's a distance between the original ray, the original incident ray, and the emergent ray. Original incident ray is the imaginary line, extended imaginary line. Yes or no? And the emergent ray is the actual line which is coming out from the glass slab. Clear?
Yes, sir.
Is everybody clear? Is called lateral
Yes, sir.
shift or lateral displacement, you can say. It has two names. Clear, Abdullah, Hiba, I'm sorry, Hiba, Karishma, Hashid, all of you, let me know.
Yes, sir. Clear, sir.
Okay, okay, that's
Yes.
great. So basically, last thing which basically lateral shift has is the factors on which it depends.
So,
Yes, Abdullah.
so can I come back in 2 minutes? I have an order to pick up. I'll just
Sure,
come in 2
sure,
minutes.
sure. Thanks, Abdullah, for informing. You can.
Yeah, thank you.
Factors on which lateral shift depends. Like this could be a 3-marker question in your school exam. Like write down the factors on which the lateral inversions, lateral displacements, or lateral shift depends. Clear?
Okay, sir.
So you have to write 3 to 4 factors. Just these are very simple factors. First one is, so when you will go in the higher standard, you will be deriving some of the formula regarding related to lateral shift. So, but in now only the factors are present here. Clear? Directly proportional. Can anybody tell me what does it mean, directly proportional? To the thickness of glass. Anybody? So basically, is directly proportional means, suppose that, okay, x is equals to y. So if you increase the value of x, y will automatically increase, yes or no?
Yes,
Because
sir.
they are, if you suppose that you put value of x as 2, y will become 2. You put value of x as 25, y automatically becomes 25 because they are equal. Which means that if I take a sign here, x is directly proportional to y, which means if you increase the value of x, y will also increase. Clear?
Yes, sir.
Any doubt?
Yes. No, sir.
Yeah. So that's what a directly proportional is. Directly means if you increase any of the material property, the another property will also increase. If we decrease the thickness of glass slab, lateral shift, which means that the distance between the two rays will be less. But if we increase the thickness of glass, so there would be a larger distance between the two rays. Clear? All of you, yes or no?
Yes, sir.
Lateral shift. Directly proportional to the incident angle. To the incident angle. Which means that if you increase the value of incident angle, your lateral shift will also increases. Clear? Third point. Lateral shift varies directly. What happened? Okay, Abdullah. Okay, Abdullah. lateral shift is varies directly proportional to the refractive index of the glass slab, which means that if the refractive index of the glass slab is more, then there would be more lateral displacement of the ray. Yes or no?
Yes, sir.
At least, please, everybody say at least yes to me so that I can like have the idea whether you are there in the class or not.
Yes, sir.
Okay. Of glass slab. I don't want that this class is an environment like school, like only the teacher is speaking again and again. Only yes, you say yes sir, yes sir. I want two-way interaction with all of you. Okay, that's why you are here. Okay, if you make this similar kind of environment in the class itself, which has school, like similar to the school, so that would be like less. So like that would be like you can say the efficiency will not be like up to the mark. So that's why I continuously ask my student to involve in the two-way interaction. Inversely. Now, inversely means suppose X is in, like this is the example of inversely. Let me tell you what is inversely proportional. Let me write down the first thing. Which means that if you increase the value of X, yes or no, your Y will, or you can say, let me take here. If you increase the value of Y, now tell me, suppose first you put the value of X, Y as 1/2. And then after that, put the value of Y as 1/4. Now tell me which one is greater, 1/2 is greater or 1/4 is greater?
1/2.
1/2 is greater, which means that
1/2.
if you increase the value of Y, X will decrease, yes or no? So that's
Yes.
what inversely proportional is. If you increase one of these property, the other would decrease, which is related to it. Clear? That's what inversely proportional is. Clear? Everybody, yes or no?
Yes, sir.
Yes.
Okay. Inversely proportional to the wavelength of light. So these are the four factors on which lateral displacement depends. Clear? Any doubt in this? Anybody tell me?
No, sir.
Sure?
Yes, sir.
Okay, that's great. So now we are going forward to the basically the image formation by the glass by the lenses. Just a second. Let me write down here emerging. Let me share my screen again. Actually, it just got freezed. Just give me a second. Sometimes happen. Let me share my screen to all of you. Just give me a moment. Now, please tell me, everybody, is that clear to all of you? Yes or no? Which I have
Yes,
taken so far.
yes.
Okay, that's great. Okay, okay. So let's start with the term refraction through spherical
Yes.
lenses, or refraction through. Just a second. So I have how many of you have S-Chan? Does anybody have S-Chan apart from NCERT? Do you follow any other book? Okay, so don't worry about it. I have now I've got one PDF of S-Chan from the internet. So I will share it with all of you. So you can have the book and take references like for this their number of questions are there on basis on on all the chapters of physics. So that would be a very good book for to all of you. Clear? Okay,
Okay,
that's great. Okay, just give me a second to So basically our topic is refraction of light. Lens. So that's what our new topic is basically. So let me paste this picture of your two lenses which we are going to cover. Because my drawing is not so much good, so that's why I'm pasting down the pictures of the two lenses. So these are your spherical surfaces by which the refraction will take place. Clear? So basically, this is a kind. These are two spherical, like you can say, this is a glass thing. You know, you all know that. You all know that the glass is like basically like some of you already wears that. Yes or no? Let me know. Clear? So this is a glass portion, and you know that this is an air portion. Clear? So as you can see that if I draw a straight line between it, just a second. You can see like just a second. Let me draw it my free-handedly. So it's a kind of, you can say, if you basically take a like this and draw a thing like this straight line. So it's a straight line. Suppose it's a straight line. So you can see that is it like the bulky surface is outside, like the exposure to the ray. Yes or no? So it's a kind of convex. So that's what convex word has been used. In the convex mirror is a kind of this thing. Yes or no? Convex mirror is a light is like basically strikes this surface, and convex mirror is a kind of this. That's what concave. Clear? So that's why it's called as concave surface. Okay. So these two mirrors are there in your syllabus, but so that's why these are called spherical lenses. Basically, if you break these two things and suppose if you take out this part of convex lens, if you complete this circle, this would be a spherical lens. Yes or no? I've told you in the mirror section the concept about this. Hiba, are you there, dear?
Yes, sir.
Why are you so late?
Sir, I was studying for my exam tomorrow and I forgot about the class today.
Okay, sure. So, like we have already covered the lateral shift definition and only the factors. So we are just starting the refraction through spherical lenses. Clear? Anybody,
Yes,
any doubt till now?
No, sir.
Okay. So let me. So basically this lens is called as converging lens. I will tell you why when we will do the image formation. So this lens is called as diverging lens. In mirror, the things were opposite. Convex was said to be the diverging mirror and the concave was said to be the converging mirror. So, but in the lens formula, in the lens concept, it's opposite. Converging lens means convex lens. Clear? Everybody? Diverging lens means concave lens. I will tell you why. You will just see this basically the image formation. After that, you will be able to judge which one is converging and which one is diverging. Very good. let me paste down one picture here of convex lens so that so let's make first thing. Let me tell you what our basics is. So this is called principal axis. And suppose this is your lens placed like this. Clear? So now everybody, just a second, let me place this. Your light rays are coming like this way. Clear? Because if there is no symmetry, so we won't be able to draw the images like in a proper manner. So that's why I'm a little bit cautious about this symmetry so that I can explain it to you in a better way. So, so this is a glass medium. Yes or no, everybody? This is air outside the, you can say the lens. So air is present, yes or no?
Yes, sir. Yes, sir.
So air is a rarer medium. Rarer means it will have a refractive index lesser refractive index. And denser means it will have a refractive index like greater volume, greater magnitude. Yes or no?
Yes, sir.
Okay. Is everybody getting my point? I don't want any flattering answer. I want honest answer. So like, so I've told you that there would be a refraction because it's a refracting surface. Glass is another medium, yes or no? So there would be a refraction, like change of path by the light. Why is everybody so silent?
Yes, sir.
Is that clear to everybody?
Yes, sir.
Okay, just a second. So, and another is will get refract in this manner, yes or just a second. Yes or no?
Yes, sir.
Very good. So basically, this is called as the middle. Like in the mirror, what this point has to be called? Like, what is the definition? What is the name of this point? How many of you know? Abdullah, this is a new topic. So please attend the class focusedly, dear. Okay. I'm telling everything from scratch of this topic.
Okay, sir.
Yeah. Anybody, Hiba, you know, Hashid, do you know? Like you were there in the class when I've told you the mirror thing. Karishma and Shweta, you are also open to answer.
Also,
I'm saying that in mirror, what this point, like what's the name of this point?
Principal axis.
sir, optical center.
Optical center is for the lens, but
Oh,
pole is
Yes,
the
sir.
name of the
pole.
pole.
Yes, sir.
Clear? So that's why revision is necessary. So this is called as optical center. Clear? This is called as principal axis, Karishma dear.
Okay, sir.
Okay. This is an what? Incident ray. And this is the refracted ray. And this ray is coming from infinity. So when at the point where they are merging, what's the name of that point? Can anybody tell me? It's the same of the mirror. Yes, yes, Hiba. Yes, Shweta.
Principal focus.
Yes, principal focus. Very good. It's called as principal focus. One. Why? it's a, you can say, two-way, you can say, refracting surface. If the ray is coming from this side, so it's refracting the like rays onto this principal focus. Yes or no? Suppose if the rays are coming in from this direction, so this is also a refracting surface. Yes or no?
Yes.
It's not like covered thing like that we had in the mirrors. Nothing is covered in this thing. You have lenses, so there is like it's a transparent thing. Yes, yes or no?
Yes.
Yes. So that's what there would be two principal focus. This is called the F1, and similar kind another focus will be here F2.
F2.
Clear? In the mirror,
Yes.
we used to say the center of curvature. The center of the spherical mirror is said to be the center of curvature. Yes or no?
Yes.
But in this, it's said to be 2F. Suppose 2F. So, just a second. Is everybody clear this? Like anybody, any doubt?
No, sir.
Sure?
Yes.
Okay. And this will be, sorry, 2F2. And same point here is 2F1. So, okay, so now let's take the convention, sign convention. Light ray is moving in this direction. This is direction of light. Now tell me, what should be the value of the, like suppose the image, you can say this, suppose the object is placed like this. Object is like this here. So now can anybody tell me what is the object distance would be what? And same thing.
Between F and 2F.
So it would be negative of u, yes or no?
Yes.
Okay, so let me give you one more thing here. We always measure the distance from optical center, whether like for lenses and from for the mirror, it's pole. So if the light there is the direction of light in this way, so this direction will be taken as positive. Okay, Abdullah? Abdullah, are you there?
Yes, sir. Yes, sir, I'm there.
So direction of light in the sign convention is taken as positive. So now I'm here and we are moving in this direction to measure the distance of the object. So it would be negative or positive?
Negative.
Tell me anybody. Yes, Abdullah?
Negative, sir, I guess.
Yes, negative, dear. If the light is going in this direction and I'm moving in this direction, so this is a negative, or you can say negative direction. Clear? Now
Yes.
I am standing here and I'm moving in this direction. In the same light is also in this direction. I'm also in this direction. Is this a positive direction or a negative direction?
Positive.
Positive.
Positive. Very good. So V will be positive. Clear?
Yes.
Yes, sir.
Now another thing, I'm moving again in this direction to calculate the value of principal. So this would be a like you can say principal focus. So this would be like for convex lenses, what would be the value, positive or negative focus? Principal focus 1. I'm asking, like in like majority of cases, you will be dealing with principal focus 1. Like there would be a rare chance to calculate the image using that. So we will be doing that, but most of the cases, 99% of the cases, you will be dealing with the principal focus 1, which is this. Now tell me, it should be positive or negative? Everybody is open to answer.
Positive.
Positive.
But,
Positive. Very good. Positive. Yeshwata, you have something like but something?
no, sir. If the image is inverse, then it will be negative.
So dear, we are not talking about the basically the image nature. We are talking about the value of
Yes.
principal focus, whether it's the magnitude of principal focus will be negative or positive. Okay,
Yes.
that's what I'm asking. You like for the convex lens image will be inversely invert. Yeah. So the
Okay.
principal focus will be positive. So convex lens has positive focal length. I'm writing 1 here because 1 is positive. But if you take if suppose in some of the question, the calculation involves the negative, like the principal focus 2. So the principal focus will be negative because you are going in this direction. Yes or no? But we are not
Yes.
talking about the exception case. We are just talking about the normal case which we will handle in this class. Any doubt? Anybody?
No, sir.
Is
No, sir.
everybody clear to this point? Abdullah, Karishma, Hashid, Shweta.
Yes, sir.
Yes.
I think who has left? Somebody has left the class. 2, 3. No. Everyone is there. Sorry, I thought that. Okay, is that clear to all of you?
Yes, sir.
Yes.
Okay.
Yes.
Okay. So let's take the image formation of the convex lens first. After that, I will be telling you the you can say concave lenses. Okay. So let's take the image formation here. So, so that basically same as the mirror, we will be having only 2 rays to form the image formation. We know we need only 2 rays. At least we need 2 rays. Yes or no, everybody?
Yes, sir.
Yes.
I will be doing everything from scratch in this example. Don't worry. Clear?
Yes, sir.
Okay. So now tell me what should be the first point of the object. Can anybody tell me?
Object is infinity. Object is infinity.
Object is at infinity. Very good. Because we basically start from the infinity and move towards the optical center, like just we had in the mirror concept. Yes or no?
Yes.
Yes, sir.
Yes, sir. Very good. So let's draw the thing. So it's a kind of convex lens. Clear? And the object is object is placed at infinity. So we'll be having only 2 rays. Okay. So what should be this point? What's the name of this point at which the image is the rays are
Principal
merging?
focus.
Very good. Principal focus. So now tell me, why have you got this point? Why this mirror lens is called as converging? Converge means diverting to one point. Got it?
Yes.
Converge.
Yes, sir.
Yes or no? Everybody got this point?
Yes.
Why does it called as converging lens?
Yes, sir.
Clear? Very good. So this is your O. Okay, this is your O, and this is your F1. Clear? Anybody, any doubt?
No,
The most simplest situation for the image formation. Clear? Let me write down the thing. U is at infinity. V at focus 1. Yes or no?
Yes.
Can anybody tell me what's the image nature?
highly diminished.
Image
The
nature. I'm not asking
real-
about the size.
The real and inverted.
Very good. So real and inverted means the image can be obtained on the screen. Real images are what? The image which can be obtained on the screen. Clear?
Yes.
Yes, sir.
Okay, very good. Image nature. Next year, image nature is real and inverted. Next thing is, this is V. This is image size. Image size is
Highly diminished.
highly diminished. Very good. Highly diminished. Highly diminished. Why? It's a point-like thing. Only the rays, all rays are merging at the focus.
Yes,
Yes
sir.
or no? Clear? So it would be highly diminished. Point size, you can say. So highly diminished is the word used in the ray optics to define the term, which is like point size. Or you can write point size. Clear?
Yes.
Suppose if you have a convex lens and the rays are coming from directly from the sun. When you focus on something, it would be a point-like image, yes or no? Very small image of sun rays which are merging, converging at focus, yes or no?
Yes, sir.
Yes.
So that's the real life example of the converging of rays coming from the infinity. So your object is at infinity almost, like sun is like lakhs of kilometers away from the like Earth. Yes or no?
Yes, sir.
The convex lens is very smaller in comparison to lakhs of kilometers. That's why we take this reference as infinity. Clear?
Yes, sir.
Very good. So let me write down the thing as infinity. At infinity. Now next thing, what should be the what should be the object distance now? Abdullah, why are you silent here? Is that clear to yes or no?
Yes, sir.
Any doubt in this? Because I'm starting everything from scratch because Karishma, Haiba, and Karishma, Shweta, and you are the new to this batch. So that's why I'm covering the image formation again. Like we have done in the image mirror as well, but I'm again doing this thing like from the scratch. Clear? So don't worry about it. Just focus a little bit. The back thing I will be taking as well.
Okay, sir.
Okay. Is everybody clear?
Yes, sir.
Yes.
Okay. So now that the object is infinity. Now, can anybody tell me what should be the next image, like the object position at this in this case, like in the next place?
At focus, F1.
Not F2. It would be a little bit beyond F2. Like that we in the mirror we have done the beyond C. There is a word beyond C. Like in the same
Yes.
this is beyond 2F2 because 2F2 is there, not F2 is there, F1 is there. Clear?
Yes.
Beyond to F2. Let me draw the thing. Everybody please take this image formation seriously because 5-marker questions can be from you can have the 5-marker question from this topic. Okay, so this is not like a minor topic, this is a major topic. You will be having like one at least ray diagram, or there would be a kind of situation given to you that this is the ray diagram, complete the ray diagram. So don't underestimate this topic. Okay, so now let's say this is your F1, not F1, F2. This is your 2F2. Clear? This is your F1 and this is your 2F1, sorry. And this is your optical center. Okay. Now your object is placed at, can anybody tell me
2F.
where?
On to F2.
Beyond
2F2, beyond 2F2. Very good. So if the object is placed at beyond 2f2, object is suppose that the object is like, sorry, just a second, I'm making an inverted object. Let me draw this again. This would be like this object, yes or no? Everybody?
Yes.
Yes? Okay.
Yes, sir.
So you need two rays to complete the ray diagram. So I'm making this ray. Just a second. So first ray is parallel to principal axis. Actually, a little bit symmetry I need in this. It's a little, now it's fine now. So first ray will be will be parallel to principal axis. This is principal axis. This is parallel to principal axis. Yes or no? Everybody?
Yes.
Yes, sir.
Sure?
Yes, sir.
Yes.
So, so this ray will pass from the focus, yes or no?
Yes, sir.
Yes, sir.
So this ray has passed from the focus. Clear?
Yes, sir.
Now tell me what should be the another ray?
Passing through optical
Yes?
center.
Like somebody has said
Optical
something.
center.
Optical center. Okay. So
Cross
Shweta, is that
center.
your answer, dear?
Yes. Sir.
Okay. Yes, Harshit. Harshit, are you there? So your next ray will be from the optical center, and this will pass like this. Just a second. Okay. So this is your another ray which is passing from optical center. It will go straight. There will be no deviation. Yes or no? Everybody tell me.
Yes, sir.
Yes. Sir.
Is there any doubt in this? Abdullah, Karishma, Hashid, Shweta, Hiba?
No,
No,
sir.
Clear?
Sir. Yes, sir.
Okay. So you have two rays. So yeah, now you can see that there is an intersection point of these two rays. Yes or no? So this intersection point is your image formation. So this is your image formation point. So now you can see that the image is formed between F and 2F. Clear?
Yes, sir.
Any doubt?
Yes, sir. No, sir.
Sure?
Yes, sir.
Very good. So now let me take some labeling. This is your U. This is your V. Okay. So beyond U is at beyond 2F2. V is at between F1 to F1. Clear? Yes or no? Now you can see that we are moving towards 2F2. The image is going like the object is coming to the optical center and the image is going away from the optical center. You can see that the same thing happens in the mirror as well.
Mom.
Clear?
Mummy. Mummy.
Shweta, dear, you can unmute yourself for a while. Is that clear? Now, can
Yes,
anybody
sir.
tell me what is the image nature?
Diminished.
Image
Sir.
nature, not size. Real
Uh,
inverted.
Sir, really muted.
Very good. Real and inverted. Now, why invert? Like everybody is thinking, what is inverted? Inverted means the object is placed upward direction, but image is forming in the downward direction. That's what inverted is. Our eye also makes inverted images. Real images are there. Yes or no?
Yes.
Yes, sir.
So our eyes also make the invert images, but our brain basically there is a image formation in our eyes which is inverted, but our brains manipulate it, so that that's why we see the world in a real, in a, you can say, erected manner. That's what the beauty of brain is. Clear? Now we can say the image size.
Diminished.
Diminished. Very good, dear. Very good, Abdullah. Diminished. That kind of interaction I want from all of you. Diminished. Like, clear?
Yes.
Any doubt in this?
No, sir.
So
Okay, so we are done with the two image formation of the lenses. First one is at the infinity. Second one is at the beyond 2f2.
2F.
Clear? Now can you predict, if I place the object at 2f2, what will be the image point at what point the image will form?
2F1.
2f1. Very good, very good. 2f1. Why? Because if you place the image at the, say, like 2f2 or the center of curvature, like the mirror, so the image will also form at the center of curvature or 2f1 in lens and mirror. I am telling both you can say both the situations. Clear? And can you tell me the size? Can anybody tell me the size of that image?
Same size.
Okay, Shweta is Hiba is saying same size. Shweta, Karishma, Hashid, Abdullah.
Same size.
Same size.
Okay, same size. So you can just a little bit predict how you can see that the image was for the first situation, like at the infinity. Hashid, are you there, dear?
Yes, sir.
Okay. The point, when the rays are coming from the infinity, the point size image was forming. But when the object just shifts a little bit towards the optical center, towards the lens, the size of the image increases. Yes or no? That was highly diminished, but it's diminished only. So there is an increase. Yes or no?
Yes, sir.
Yes,
So,
sir.
but similar thing, but when you place the object at 2f2, same size of image will form. It will increase a little bit and it will be of same size. Clear?
Yes, sir.
Any doubt in this?
No, sir.
Okay. So let's let's end this class here, all of you, because time is already up. Only 1 minute is left. So we need to end this class here. Okay. So all of you can leave the class. Thank you so much for coming to the class, and we will be doing the things in the remaining class. In the coming 2 classes, we'll be done with the light chapter. Yes, only 2 classes will be required, like the coming one and the next one.
Yes, sir.
Okay. So
Yes.
I will. So because electricity chapter is a very lengthy chapter, so I need much more time to explain that chapter to you in a very detailed manner, because some very lengthy chapter you can say. So that's what. Okay.
Yes. Thank you.
Any
No,
doubt?
sir.
Anybody?
No, sir.
Okay.
No, sir.
Okay, dear. Okay. Okay, all of you. Thank you so much for coming to the class, and take care.
Thank you, sir.
Welcome, dear. Welcome.
Thank you, sir.
Abdullah, yes, yes. Thank you, Shweta. Abdullah, dear, you were saying something. Yes, let's just we have 1 minute so we can say that thing.
Yeah, sir. I have my science exam tomorrow, and electricity is there.
Yeah, Abdullah, I was saying that thing, that electricity chapter is not a small chapter, dear. Shweta, dear, you can leave the class. Thank you so much. So
Yes,
electricity
sir,
chapter.
but homework.
So electricity chapter is yes, Shweta, dear.
You have approved some homework. I didn't get that.
Actually, your voice is not coming.
So you have uploaded some electricity, no, mere refraction questions. So I didn't get that.
Okay, okay, Shweta, I will look into that manner. I got it that you didn't receive the homework. I will talk to the management and let you. They will like in the next time this won't happen again. Don't worry about it, dear.
Okay,
I will
sir.
take care of all
Okay,
my
sir.
students. Thank you so much for informing, dear.
Thank you, sir.
Okay, yes, Abdullah. So I was saying that dear, electricity is not a small chapter. So even if we take the 2 classes, they won't we won't be able to cover so much syllabus because you need the depth of that is you can say chapter to basically to attempt.
Yes.
Okay, so that's why I thought that we had a class on Sunday. So I was thinking that we can schedule one class for you, but just I forgot that we had a class like our batch classes on Saturday. Actually, there was a 9th class of physics on Sunday, so I just misinterpreted that. So that was my fault. Sorry for that, dear. I thought that I can schedule one more classes for you.
Okay.
Okay,
No problem.
so okay, thank you so much, dear. But you need a little bit more patient about this, dear. So don't worry about it. We'll be doing everything. Okay.
So,
Like
sir, what can I do for tomorrow? Like, my chemistry and bio is done. Like, I've done it by myself, but like only physics I had problem.
okay. So dear, you can do one thing. You can have some. You can memorize the definitions. Electric current,